Alright, so here's the next one. We were trying to make a regular pentagon, and what happened?
It messed up. So, I guess we told Mathematica the wrong thing, and it looked so similar to a regular pentagon we didn't actually notice it.
Yeah, it's funny. We tried to make a regular pentagon, and we unluckily had a little error in our code it looked fine on the screen. In fact, even looking at it now on the screen, it looks fine. But when it printed, it's a little high. But we found what the error was.
Yep.
So that's fine. So we almost made a regular pentagon. What we'll do is
Go through the steps.
yeah, go through the steps. So show me what you did to make this, because this was really neat.
Can I draw like a larger version of it?
Yeah, draw a larger
So,
version of that.
Draw in our regular pentagon. I said the side length was just going to be 1, so all of these are 1. And then we found the interior angle of the pentagon to be 108 degrees. So since a triangle is 180 degrees square, and it goes up by 180, so a square is 360 degrees. Pentagon's interior angles summed up 540 degrees, and there's 5 of them, so 108 degrees for each angle,
Okay,
since
good.
it's a regular pentagon.
Nice.
So that means if we drop perpendicular here and extend this side, this angle here is going to be 72 degrees. Since this is 1, we know that we're going over in this direction, cosine of 72 degrees, and we're going up sine of 72 degrees. So then we figure out that this point is negative cosine of 72 degrees, sine of 72 degrees, since we're going the other way, in the x direction.
Okay, good.
This over here, we can do the same thing, except that this point here is 1, 0. Draw that a little bit. This is also cosine of 72, this is also sine of 72 degrees. So then that means this point here is 1 plus cosine of 72 degrees, sine of 72 degrees.
Okay.
Now we have to figure out these triangles up here. So if this is 72 degrees, that means this angle here is 18 degrees. This is 108 degrees. So that makes this angle here, this is 126 together, so it's going to be 54 degree angle here. That makes this 36 degrees. And then it will be mirrored on this other triangle here. This will be 18 degrees. This will be 54 degrees. This will be 36 degrees, and then we can check 36 degrees plus 36 degrees, 72 degrees, plus the 108 is going to equal 180.
Okay, good. Good job.
So from this side, from this coordinate here, we go over cosine of 36 degrees, and we go up sine of 36 degrees. So this coordinate will equal negative cosine of 72 plus cosine of 36 degrees, and sine of 72 degrees plus cosine of 36, sine of 36 degrees.
Yeah, and actually that's the mistake that we made on this. We actually did put in sine of 72 plus cosine of 36 accidentally, so we made it too high.
Yep.
But that's all right.
So now we have all of the coordinates, and we put this into a function, convex hull 3D that takes a series of points that are in three-dimensional space and finds the convex hull that creates a shape.
Yep.
So we entered two versions of these points. We entered one set of all of these points with a z height of 0, and then one with a z height of h, so we could configure it to whatever we wanted. I think we put it as 0.2.
Okay, cool.
And then we made the hull and printed it.
Nice. And there was one really neat bit of geometry here that we learned about cosine of 72. Do you remember what that was?
Well, since this is a regular pentagon, it's going to be symmetrical. So if we drop a perpendicular here, it should split the side in half. So the x-coordinate here should be a half. So we know that cosine of 36 degrees minus cosine of 72 degrees is 1/2.
Yeah, cool. That's really neat, actually. So we don't know even necessarily what cosine of 36 and cosine of 72 are.
We know they're half.
We know they're a half. We necessarily know the difference is a half. It'll turn out, I can show you later if you want, that cosine of 36 degrees is square root of 5 minus plus 1 over 4, and cosine of 72 is square root of 5 minus 1 over 4. So the difference is 1/4 minus 1/4. You get a half.
Yeah.
That's neat. Yeah, this is really good work. What do you think about printing these 2D objects and studying them through 3D printing?
I think it's a neat way to learn how to find different angles and sides in terms of cosine and sine.
Yeah, I think so too. I think it's a fun trick. Great job, huh?